What's going on, everybody? Thank you very much for watching. I appreciate it. Charles Weinraub AKA the Handsome Homebuyer, and on this week's episode, we were honored to be called out to speak at the Global Real Estate Summit in the greatest city in the world, New York City. Over 700 people attending, both online and in person, to talk about SQ4D and 3D printed house technology, exactly how it works, exactly why SQ4D is the best. Tons of great information is going to blow your mind. This is not a trend, this is not a wave, this is the future, and it's happening right now on Long Island.
Thank you guys very much for having me. I really appreciate it. I'm super excited to talk to you about this. 3D printing it's definitely the future. It's really the now. It's happening right now. So just so I know who's in the room, out of curiosity, realtors, raise your hand if you're a real estate agent. What is everybody else? Mortgage people, et cetera, developers? All right, so mostly in the real estate agents. So, first slide. Oh, there we go. Okay. Everybody familiar with a trend, a wave, right? Now we're all in the real estate industry, so wood paneling, shag carpeting, waves, right? Trends. They start, they have a crest, they end. 3D printing is the future, right? What you guys are going to see today, imagine this for a minute. 10 years from now, you're going to bring a buyer to a piece of land. They like that piece of land. They're going to put a headset on in virtual reality. They are going to design their home, move walls, add bedrooms, change colors, buy their furniture. A 3D printed machine is going to pull up with one or two people, print the house on site, which includes everything in it: cabinets, doors, moldings, everything. This is what is happening literally right now, and it's happening right here in Long Island in Patchogue, New York, which is very cool. And I'm very blessed. Yeah, that's what I'm talking about. And I'm very blessed to be a part of it. So I want to take you guys on a little journey, explaining who we are as a company, what the current issues with construction are, where 3D printing came about, and why we feel that we're the best and we're going to lead the charge of the new revolution, or evolution, I should say, of 3D printed homes. So who am I? For better or for worse, you may agree, may disagree, but just as long as you remember me, I'm happy. I am known as the Handsome Homebuyer. So I am the #1 fix and flip investor on Long Island. I flip anywhere from 70 to 110 houses a year. I've been in the business for 6.5 years, and I've flipped over 400 houses in the last 5 years. Thank you. I recently went back to NYU to get my master's in real estate development, and now I pretty much do everything from non-performing note purchases to commercial development in the assisted living facility space, affordable housing, retail, etc. I try to do it all. I love it all. It is the greatest business, and I'm so blessed to wake up every day and love, love, love what I do. Recently, I become a board member of this company, SQ4D, which I'm about to explain what they do. So let's talk a little bit quickly about the construction industry as a whole. Construction industry has been the same for a very long time. There have not been any major disruptors that we know. We had a lot of issues, but COVID really magnified those issues. What type of issues am I talking about? I'm talking about a lack of skilled labor. I myself own my own construction company. We're completely vertically integrated. I control every part of the process. I need to hire 10 construction employees today. I cannot get one. Right? Stores are going out of business, closing early because they cannot get employees. It's a major, major, major problem. We have supply chain issues, massive fluctuations in material costs. I paid $12.50 for a 2x4 30 days ago. A year prior to that, it was $3. I mean, what does that do to builders who have pre-sold houses at scale? I mean, it'll basically put you out of business. Insurance is very expensive. Obviously in New York, that's an even bigger problem than most other states. Limited warranty, meaning when you're stick building houses, they're not resistant to fire, they're not resistant to water, they're not resistant to bugs. These are things that I've dealt with. And through the process of doing hundreds and hundreds of houses, I realized, this is a major issue. And because of that, my business is only scalable to a certain point. because of that. So enter SQ4D. I'm the handsome guy in from the left with the hat on. SQ4D is right here in Patchogue, New York. A very close friend of mine invented the technology. He has a patent on the tip. He is absolutely brilliant. Their saying is, or their slogan is, changing the way the world is built. He's been in business for 4 years. He is 100% self-funded. And the way this happened is, I don't know if any of you guys have dealt with municipalities, especially on Long Island, in New York, building departments, unbelievably difficult. It's very, very, very hard. This area in the Northeast actually has the longest permit process. I believe it's a little bit over 11 months on average, start to finish, between the time you open a permit and then ultimately close a permit, which is obviously not good for anybody. So this gentleman, Enzo Pagani, went into the building department in Patchogue, and he's trying to renovate a house, and they were giving him all kinds of problems and delays. And he said, you know what? I'm going to build a robot. The robot's going to build the house, and you can talk to the robot. And that's exactly what he did. Sick, right? I get goosebumps talking about it. So let's just talk very quickly about the history of the 3D printer. Most of us, when we think about 3D printers, we think of things like this, that like print phone cases and all kinds of different stuff. It was originally, people don't know this, they think it was a pretty recent invention, but it's not. The 3D printer was actually invented to build houses in 1947, but the technology had multiple patents, layers of patents that actually kept it locked up until 2009, where Bree Pettis had a company named MakerBot, and they came out with the first 3D printer similar to this. Today, a little bit more than a decade later, 3D printing is a $200 billion industry, and this is just with plastics. Crazy. So, SQ4D. This is the machine. It's essentially, if you look closely, it is what I just showed you that was printing out the plastics, just massive. And they get even bigger than this. So essentially what it is a gantry setup where it's 35 feet wide by 18 feet. This is the first generation of it. It works off of G-code and CAD. Anybody here familiar with architecture, CAD? Okay, so essentially what G-code is a sequence of numbers, and then CAD is the process to follow those numbers. So I would generate a CAD file of a house, the architectural plans, and they would program the G-code to that, and the machine prints on its own, by itself. All right, it works also with a volumetric mixer, which is, and I'm going to show you pictures of all these things, because when I talk to people and they're like, oh yeah, we're 3D printing houses, they're like, what do you mean you're 3D printing houses? Like people can't really wrap their head around it, even myself included, until I really came to the site, saw the equipment, saw how it was working and how it comes together. So we have a custom volumetric mixer, which essentially what that does is that mixes the Portland, sand, and water together on a conveyor belt, and it feeds it into a cement pump, which very slowly pumps it through a hose system as it's printing along, going around and around and around until the house is done. All right, 2 people. When you think about anybody here ever seen a new house be built, right? It's a very labor-intensive process. You have like 15 guys running around framing the house, roofers, all that. This machine takes 2 people to operate it. 1 person monitoring the machine with a remote control if they need to override, and somebody just working the volumetric mixer to make sure there's a constant flow of cement. That process will end up being automated, and this will end up being, in the not so distant future, a 1-person operation. Not to jump ahead too much, but the second generation machine that they're working on is going to be able to fold up into a small U-Haul-esque size trailer and be put together by 1 person. Crazy, right? Yeah. How does it work? Okay, so homes are printed on site. Right now it's a slab on grade construction, meaning they're not doing basements currently. No one's ever done basements. As a matter of fact, I'm going to show you guys, we're doing what literally nobody else has done in the world. As a matter of fact, we obtained the first, in my opinion, permit to legally 3D print a house in the country. There was a couple other houses that were printed in different parts of the country, but they were in areas where there were experimental zoning, and it's not as strict. The bottom line is, anybody who knows New York knows that it's the hardest place to do anything. Can I get a hell yeah? Yeah. Hardest place to do anything. Slab on grade construction, no basements, but that is coming. Footings and foundations are dug and then 3D printed. We are the first people that we know of that has done that anywhere in the country. Normally what happens is the foundation and the footings are poured prior by a traditional concrete vendor, and then it's printed on top, and most people use wood and things inside. We don't. We are actually printing, and if you see in the picture, you could see right there that the line comes down, and what we are doing right there is we are printing the base in which the footings and foundation will go on. So when we do the footings and foundation, there's a 10,000 PSI Portland slurry. Slurry is a little bit more watered down concrete. The more water you have in concrete, the stronger it is. So after we dig out around for the foundation, that goes in, gets very hard, acts as a base. And then what we do is we take a 7,000 PSI mixture, which, just to put into perspective, that's what they use in skyscrapers. It is very, very, very strong. Like if you were pouring a normal slab in your garage, it would be somewhere between 3,000 to 4,500 PSI. We're at 7,000 to 7,500 PSI. It is very, very, very strong. Okay? The walls themselves, and I'll show you a picture following this so you guys can kind of understand a little bit more how this works. The walls themselves are hollow. There's 8 inches between the walls, and there's a zigzag that runs between them for structural rigidity, and there's 5-inch voids. That's where the spray and insulation goes, the electric, and your plumbing. Like I said, it's a type 3 Portland mixture, and the reason why that is so important is because it dries extremely fast. So this machine is putting layer in layer. The one layer can accept the next layer in 7 minutes. So one layer dries in 7 minutes, fast enough to accept the next layer and the next layer. Once you've printed the entire property, within a week to 10 days, you can accept the roof truss system and keep going. So it's very, very, very fast. There is rebar put in, so we would lay rebar in there. If you see on the picture, we would lay rebar in for rigidity. Rebar also goes in 2 sticks around each side of the exterior structural doors only. So there's not that much needed. And then as far as the roof goes, currently what we're using is a roof truss system. So it's a pre-manufactured roof system that comes in and we just pop it on for speed, cost effectiveness. The really cool thing about this product is it's very affordable, and you'll see the cost savings as I go through this, which will blow your mind. But it's not just for cheap, it's for everything. It can solve the affordable housing problem. It could also go into very cool, modern Hamptons properties. You can use it for anything. All right, so how it works. These are just some pictures to show you guys. If you look on the left, that is the forms that we're printing. So if you see those little grooves that go through there, that's what I was talking about before. If you look to the right, that is the pump. So the volumetric mixer is over it. It'll consistently drop the Portland mixture into the pump and then feed it through the hose, which you see just behind that gentleman there. There is the volumetric mixer on the left. It's custom made for this. Normal volumetric mixers crank out cement much, much faster. We cannot do that with this because obviously it is going through a hose and being printed. That gentleman, that handsome gentleman on the right, he is the one that's actually controlling the machine. He has like a little kind of joystick set up in his hand, if you would, and he is running it around, back and forth, however he sees fit. Utilities and finishes. Now, this was a demo house that we did. So let's get into the utilities and the finishes, how it works. So insulation. Everybody's always asking me about R values, about green, about that's a big thing now. Blow tests, etc. The building departments are very strict on that stuff. Anybody familiar with R values? Okay, so basically R values are how well you keep the heat in. If you look at insulation, R30, R19, the higher the number, the bigger the R value, the more it keeps heat in. So people always ask me, what's the R value? Because it's concrete. You're working with concrete. People think concrete, they all of a sudden think cold. But that's not the case at all. the wider the walls, like we can make 10-inch walls, 12-inch walls, whatever it is, and fill that with spray foam insulation. So if you want R50, R90, like we can give you anything you want. So you can make it as energy efficient as you would like. So whatever your heart desires, essentially. As far as the MEPs, for those of you who don't know, that means mechanical, electric, and plumbing. There's a number of different things that you can do here. We have a big project that we're currently doing right now that I'll talk about where we're trying to go as green as possible. So we're doing very cool stuff like gray water systems to recycle the water. We're doing solar panels. We're going to be doing geothermal. But essentially, whatever you have in a traditional house, you could do. You could do electric heat pump setups. You could do gas. You could do baseboard. You could do whatever. Because think about this for a second. Whatever, and that comes to my next point, which whatever you can dream, you can build. This is an AutoCAD file and a printer with concrete coming out of a hose. You can do round turns like you see in the back of this picture here. You can do designs. You can print anything you want. There are no limitations, all right? And like I said before, you can have this, for all the smoke and mirrors, let's be real here. It's just a house built out of concrete. And this has been happening forever. They're in tropical climates, they're everywhere. The only difference is the way we do it, the efficiency, the cost effectiveness, the structural rigidity, that type of thing. So this can be something that looks like a traditional home. Like this actually looks very futuristic and whatnot for obvious reasons. This was the demo house. It doesn't have any electric and plumbing. But you could cover the walls with sheetrock. You could put wood flooring in. You can make it look like any other house to conform to any area, but it's better, cheaper, and will last a lot longer. All right, just to give you an idea also, we're currently giving 50-year warranties on the structure itself. A new construction home typically gets a 1-year warranty. SQ4D is giving 50 years on the concrete printed structure. Okay? So what do you get and what does it cost? You get better, stronger, cheaper, faster, and more. It's that simple. It does all of that. It prints, so roughly to print a house like that, this is the demo house we originally did, it takes 40 print hours to print foundation, interior, and exterior walls. The total construction time is 3 months. That's soup to nuts, drop your furniture, or your furniture will be there in your 3D VR environment. Move in, dog, kids, family, done, okay? But the biggest thing is, look at the bottom point. The cost of the entire build is 40% cheaper. But think about it, why is it 40% cheaper? Insurance, less people, it's safer, it's faster, across the board. And that's now. We're only getting better, we've only really just started. This is only really becoming mainstream now. Okay? This is a concept house. So originally when we wanted to do this, our biggest issue has been obviously adoption on the municipal level. Because this is like George Jetson type of stuff, right? So to get the municipalities to understand, even though it's a concrete house, and people have been, if you go into a Starbucks or anything like that, those are concrete structures. You go into any strip mall, those are block concrete structures. We needed the municipalities to understand and accept it. So what we did was, Riverhead Township out on Eastern Long Island, for those of you who are not familiar, are amazing. And they said, you know what? Build a house, no electric, no plumbing. Build it, let it sit there for a year. We want to see what it looks like then. So we built a 1,900 square foot slab on grade inline ranch. And they came back a year later, and it looked exactly the same as the day that we did it. And they said, we'll give you a permit for it. So they did. So now we're running a number of current projects. Enzo and the guys are actually in Riverhead right now, printing the first legally 3D permitted in the country, in our opinion, 3-bedroom, 2-bathroom ranch, inline ranch, literally printing it right now. Right after that, I have a development in the village of Islandia, which is also out east in Suffolk County. Jake's 58 is there, for those of you who are familiar with the area. I'm going to be doing a 4-bedroom, 2-bathroom inline ranch that's a little more than 2,000 square feet. We have a 25-lot subdivision that we're closing on in about 2 weeks in Riverhead Township, which will be the largest 3D printed subdivision in the world. It's going to have geothermal heat, solar, a Tesla charging station in every garage, a gray water system so the rainwater is harvested and then used to irrigate the lawn. It is awesome. And we're also about to start on the first industrial building, which is also in Riverhead, New York as well. So what does the future look like? The future literally has no limits. Just to give you an idea, I say this is the future, but it's actually the now. So SQ4D has a VR setup, a VR program. If you go to their website, I encourage everyone to do that. It's sq4d.com. You can actually see what this looks like. So essentially, the first time I met these guys, they sat me down in a chair, and they put the goggles on me. And I've never actually done any kind of VR. I don't play video games or anything like that, so this was really new to me. And all of a sudden, I'm on a street in front of my house. And I start walking down my block. And I walk up to my door, I turn the doorknob, and I'm inside my 3D printed house. And I press buttons, I sit on the couch in my 3D printed house watching TV. And I have a remote control, and I press different things, and based on what I'm pressing, the colors of the walls change. The walls move, right? I have wood flooring. I have laminate flooring. There's furniture that pops up. What kind of furniture do I want? Started out with the slab on grade single story ranch because that was the easiest to do. Once you get to the second story, and we're trying to keep it all 3D printed. A lot of these other companies are putting wood inside and they're just 3D printing certain sections. Like, we want the printer to do everything. We had to figure out structurally how we could handle the second story. So that's why that's coming out in the Generation 2. Miss?
Yes, is that also the reason you're not doing basements now because of the technology?
Exactly.
But that has a big plus because Mamaroneck got slammed with the flood and they're talking about doing away with basements. They were like, every house that had a basement. So maybe that's progressive that it's going to be on slab, right?
We will do basements because people love them.
I know.
A lot of townships don't like them because people rent them, and it's just issues across the board. But like I said, we were the first people, and this just happened 2 weeks ago, to actually do the foundation with the printer. Basements are coming, and they'll be here next year. Sir?
There is a natural alliance between what you're doing and a carbon scraper technology.
Carbon what?
Carbon scraper technology.
Okay.
Carbon scraper technology takes carbon out of the atmosphere.
Yes.
And it can be placed anywhere.
Yes.
And in fact, the more disseminated it is, the better, because once the carbon scrapes out of the atmosphere, it is extremely heavy.
Yes.
So putting a 3D printer next to that, printing out things like pipes, structural elements, your rebar, seems to be a natural continuation.
Exactly, and that's the ultimate goal with green, is to infuse the concrete with carbon in order to essentially make it carbon negative. That's really what we want to do. Sir?
What about on the lateral? Yeah, I understand you have vertical seismic ability, but on the lateral side, can you deal with earthquake country?
They actually just awarded the first permit, not us, but they awarded the first permit in California to a 3D printed company.
Do you know what city?
I don't remember the name, I'm sorry. So that's coming.
But it's interesting about the carbon, because concrete is also known to be a major carbon
Generator, yes.
generator.
Exactly.
So to be able to offset that with carbon, with being able to absorb carbon, I think is an essential element.
Without a doubt, without a doubt. Yes?
One quick thing. How about using this in a place like Puerto Rico where they just had and Haiti, I think also.
Exactly.
Yeah.
Yeah.
Would this be able to, where there's been a devastation where we just wipe out what's there and replace it with this product? Would that work?
Without a doubt. I mean, these machines essentially, if allowed to, can run 24/7. They don't get tired, they don't get sick. Weather doesn't have a huge impact on it. It's interesting that you asked another question. I'm glad you did, because the one limitation we currently have that's an issue in New York is cold weather. So ideally, you want to print in like a 50s and 60s environment. Even hotter is fine. But when you get into the 30s, concrete has water in it, it freezes. You have to tent it and then heat it. So that is currently a a restriction right now. Miss?
As you get buy-in from more towns, how difficult is it to scale up by having another machine?
Yeah, that, believe it or not, for as elaborate, she says, as we scale up, how difficult is it to scale up production of the machines? So for as elaborate and techy as all this is, and believe it or not, I'm not a tech guy. I still have an AOL account. The machines are actually very simple to build and put together, and we're looking to hopefully manufacture those right here in Long Island. Sir?
Do you have a ballpark cost for the machines?
For the machines?
I think you mentioned you were going to sell them.
Yes, so machines are going to be somewhere in the neighborhood of like $1 million to 1.2. In the back.
This question comes from an off-site attendee. They ask, can the company build a house on a cliff, or do they need a flat lot from the beginning?
Can they build it on a cliff? So I assume, yeah, like Long Island, New York, we have on the North Shore, it's very hilly. Yeah, I mean, it depends on what your limitations there. Obviously, if you have to put some kind of piles in or helicals or whatever it is to have a firm base or a secure base, you can print on top of that, just as long as you have something secure, yes. Sir?
So I'm just thinking, you said that it's an 8-inch thick wall with a 5-inch void, so I
Yes.
assume that's where you're going to run your pipes and your electric.
Exactly.
And then there has to be some type of vertical support in there for the roof trusses or for the window framing or the door framing. There has to be something more than just an inch and a half of concrete on the inside and the outside, right?
So no. So yes and no. So the exterior structural openings, like the windows and the doors, exterior, not the interior, get 2 sticks of rebar, 2 on each side, and then a steel lintel that goes across the top. But the concrete itself at 7,000, 7,500 PSI is enough to handle the weight on a 1-story ranch without a problem. Miss?
I think you're already doing that in New Jersey, because I heard this from one client who just bought a house.
There's a company, that moved there. I believe they're a Chinese company. I think Hyundai, I don't know if it's Hyundai is backing them. Is it Cobot or they have like a kind of robotic arm type of thing. They just moved to Jersey, yes.
Yeah, because the big car garage,
Yeah. 3D printers are coming. There's a lot of people that are really like banging on the door right now. This stuff has been in R&D for a while, the last 5 years really heating up, and this is really the moment where they're going to start to become mainstream. Miss?
Hello.
Hello.
You already said about the cost of the machine. Do you have an average of price per square foot to build it? And about climate, insulation?
So the first part, so it really depends. So, and here's something I should touch on also. The bigger the house, this is kind of interesting. The bigger the house, the more money you save. Because the concrete mixture, it's concrete, it's cheap. The hardest part is the initial, or the most expensive part I should say, is the initial setup. Once the machine is going, it takes, if you want to do 2,000 square feet instead of 1,500 square feet, it's another day and a half, another 2 days. You have 2 guys operating, and they're making $200, $250, $300 a day. The concrete is inexpensive. So the bigger it is, the better the value is there. As far as the insulation we were saying before, whatever you want, we can achieve. You just need more room between the exterior walls so you can fill it with spray foam, and you'll get better R values. I'm sorry, what was the first question though? There was one other part you said.
Average cost per square foot.
Oh, average cost per square foot. So, yeah. So it depends really on like the level of finishings, obviously. But if a current like builder developer like myself is building at $150 a square foot, all in, we're looking at $85 to $100 a square foot for this. Sir?
Have you sold anything yet?
Yes, that house in Riverhead that's being printed right now was pre-sold. You guys may have seen it. It was everywhere. NBC. I mean, we were literally. It was global news.
Price range?
That particular house. So this is the cool. That particular house was listed for $299, sold for $350, and the builder Enzo, the gentleman that invented it, He bought the land for $175 and made money.
And he used a realtor, of course.
No, he's not a realtor. Oh yes, he used a realtor. He used Realty Connect USA. Yeah, Realty Connect USA. I think I got to get out of here, right? Sorry guys. One more question or no? I'm good. One more question? I would take. Who has a question that hasn't asked a question yet? All right, that made it easy. Thank you very much for having me. I hope I was entertaining, if not educational. Hopefully both.